Good day everyone, my name is Emmanuel Luis Salamat and I'm going to be your reporter for today. Today we're going to tackle about the characteristics of sewage analysis required and sampling. So first, what is sewage analysis? Sewage analysis is a widely applied internationally as a tool to measure and interpret drug or reagent use on water within the community. The most important factor to take into account is that in the most communities, the principal risk to human health derives from fecal contamination. In some countries, there may also be hazard associated with specific chemical contaminants such as fluoride or arsenic, but the levels of these substances are unlikely to change significantly with time. Thus, if a full range of chemical analysis is undertaken on new water sources, and repeated thereafter at fairly long intervals, chemical contaminants are unlikely to present an unrecognized hazard. In contrast, the potential for fecal contamination in untreated and inadequately treated community supplies is always present. The determination of wastewater quality set forth in environment permits has been established since 1970s in a series of laboratory tests focused on four major categories. So, the four major categories are organic, solids, nutrients, and physical properties, and other impacts parameters. So first, the first one is the organics. Organics, in definition, is a determination of the concentration of carbon-based compounds aimed at establish the relative strength of wastewater. For example are biochemical oxygen demand, chemical oxygen demand, total organic carbon, and oil and grease. So the next one is the solids. Solids is a measurement of concentration of particulate solids that can dissolve or suspend in wastewater examples. Wastewater. Examples are solids, total suspended solids, total dissolved solids, total volatile solids, and total fixed solids. So next one is the nutrients. Nutrients is a measurement of the concentration targeted nutrients like nitrogen and phosphorus that can contribute to the acceleration of eutrophication. So example of this is the natural aging of water bodies. The next one is physical properties and other impact parameters. Analytical tests designed to measure a varied group of constituents directly impact wastewater treatability. For examples are the temperature, odor, and potential hydrogen turbidity and odor of the water. So the next one is the sampling. So in sampling of wastewater, there are two general sampling procedures. So the first one is grab samples or grab sampling. So grab samples is just what it sounds like. All of the test materials is collected at one time. As such, a grab sample reflects performance only at the point in the time that the sample was collected, and then only if the sample was properly collected. A grab sample is defined as an individual aliquot taken over a period of time not to exceed 15 minutes. For example, scooping up in a cup from a bucket. Of course, the cup and bucket methods just described is just an example. You wouldn't actually sample wastewater in that way. A grab sample is typically taken manually, but some automated samplers can be programmed to take grab samples for you. Grab samples are taken for extreme condition and for batch discharge operations. Grab samples are preferred for reviewing pollutants that changes quickly with time, such as the pH, temperatures, and bacteria. So the next one is the Composite samples. Composite samples consist of all collections of numerous individual discrete samples taken at regular intervals over a period of time, usually 24 hours. The material being sampled is collected in a common container over the sampling period. The analysis of these materials collected over a period of time will thereafter represents the average performance of wastewater treatment plant during the collection period. So composite samples are appropriate for showing the average discharge over a period of time and can be either time or flow proportional. All of the aliquots are combined in a composite sample and are delivered into a single sample container. Composite samples can be taken manually or automatically using a sampling device. So the next one is the collection of samples and its guidelines. So the first one is the sample of site collections. So one objective of this is the surveillance. So the surveillance is to assess the quality of the water supplied by the supply agency and of that at the point of use so that samples of both should be taken. Any significant difference between the two has important implications for remedial strategies. So next one is the storage of samples. So samples must be taken from locations that are representative of the water source, treatment plants, storage facilities, distribution networks, points at which water is delivered to the consumers, and points of use in selecting sampling points. So each locality should be considered individually. Although recommendations may vary, the time between sample collections and analysis should in general not exceed 6 hours, and 24 hours is considered the absolute maximum. It is assumed that the samples are immediately placed in a light-proof insulated box containing melting ice or ice packs with water to ensure a rapid cooling. So, so the last one is the recording of test results. So in this, you should put a proper labeling on the samples, and of course proper pen and where you will write the results, so sample location, sample time, field test result. So include any special notes if there is. So the results of analysis are of no value if the samples tested are not properly collected and stored. This has important consequences for sampling regime, sampling procedures and methods of samples preservation and storage. Make sure to record all the samples and carefully with the labels to obtain the result accurately. So that's all for today, and thank you.